Hello everyone. So we are going to continue today's lesson with dividing polynomials or monomials expressions. So in this case, we've already kind of gone over how to divide a monomial expression, but we've done very basic ones like numbers 1 and 2 in our examples, and we're going to get to more difficult examples like number 3, and then get into expressions that have negative exponents as well. So just as a start off point, we always want to start off with just 3 general steps. First step being is we're going to rewrite it, and I'll get into what that means. So we're going to rewrite our expression. Then we're going to simplify our expression. And I'll get into the third one after number 1. Well, actually, let's do it right now. We're going to make all exponents positive. So that's what we want to do. All right, so for number 1, we want to just review it as a recap, remembering that the rule is when we have a division of the same variable, we do the shortcut, which is subtracting the exponents. Remember, again, if I have 10 x's on the top, and then I divide by 7 x's on the bottom, seven pairs will cancel out, which means I will have a total of 3 left over. And again, instead of me writing 10 on the top and then writing 7 on the bottom and then canceling them out, the shortcut is just to take away and subtract the exponents. 10 take away 7 because 7 are canceling out. There's 3 left over on the top because there's more x's on the top. So when I say rewrite on number 1, I mean I'm going to take this expression, 8 over 20, and I'm going to rewrite the exponent as 10 minus 7. Later on, you probably will skip the step. When I say step 2, which is simplify, I mean 2 things. Actually subtract and simplify the fraction, which means either divide it if it divides nicely or reduce the fraction. Now in this case, the fraction can be divided by 4 to reduce it. So I'm going to end up with 2 over 5 x to the power of 3. All right, let's go ahead and do the next one. I'm going to go ahead and rewrite it first. I'm going to have 15 over 25 x to the power of 8. And I'm going to take away a negative 2. So it's not take away 2, it's take away a negative 2. This is a very common place to make an error. So again, in this case, I'm going to divide to reduce by 5. So I'm going to get 3 over 5 for my fraction, and then x to the power of 8 minus a negative 2 is 8 plus 2, so the double negative becomes a positive. That's going to give me a 10. All right, next one, we're going to, same thing, we're going to take our fraction, 12 over 16. It's going to be x 10 minus 8, y 12 minus invisible 1, and z 5 minus 5. All right, we're going to go ahead and divide this by 4 to reduce it. So that gives us 3 over 4, x to the power of 2, y to the power of 11, and 5 minus 5 is 0, so the exponent is 5, z to the 0. Now as an extra step, anything to the power of 0 always eliminates. So it becomes a 1. So you can see it at the top. You can cancel this with this, so it kind of goes away. So anything to the power of 0, so I'm going to go ahead and write a little rule up here, like x to the power of 0 or anything to the power of 0 equals a 1. So that's why you can just get rid of it, unless there's nothing else there. All right, now for number 3, which is this right here, this 3 right here, which I said make all exponents positive. So looking at our answer, all our exponents were positive. But what if our exponents are not positive in our final answer? We need to make them positive. So there is an actual exponent rule for this, and it's the following. So let's say we have any base x to the power of a negative number. Let's say negative a. We can't put a number, we're going to put a variable. We can always make it positive by moving its position from the numerator to the denominator, or backwards from the denominator to the numerator. So we just flip it over from one spot of the fraction to the other part of the fraction. So it makes more sense in use when we actually get to the examples. So let's go ahead and see how this works. So we're going to go to number 1 and see how this rule works. All right, so how do I make this exponent positive? So remember, if I'm looking at x to the negative 5, there's nothing to actually multiply or divide here. I'm just going to make the exponent positive. So just using the rule, it's currently in the numerator. It's going to go to the denominator, but the exponent becomes positive. That's the whole point of the movement. And since there's nothing at the top, we just put a 1, because remember, there is a 1 there. Same thing for number 2. It's currently in the denominator. I can move it to the top and make it positive. And there's nothing left at the bottom. You can put a 1, but that just becomes a to the 7. Because dividing by 1 does nothing really in terms of affecting the exponent. All right, let's look at the next one. So we only have one exponent that's negative here, which is an m to the negative 1. I want to make that a positive exponent. So it's currently in the numerator. I'm going to move it down to the denominator to make it a positive 1. P4 is already positive, so I do not want to move it. I want to keep it at the top. And 7 is already positive. I want to keep it on the bottom. And I made all my exponents positive. Let's look at the next one. Number 4, I have the x to the negative 4. It needs to move, and so does the a to the negative 1. So when I write this, the x to the negative 4 will go to the bottom, and it becomes positive. The y3 stays at the top because it's already positive. Now the bottom, the a negative 1 goes to the top because I want it to become a positive 1. And the b5 stays at the bottom because it's already positive. So we're only moving the things that are negative from top to bottom. That's what the negative to positive exponent rule is. So looking at this next one, we're going to have to go ahead and move this one and that one, the s and the q. So the r10 stays, the s4 goes down, the q negative 3 goes up, and the T7 stays at the bottom. All right, I want you to try number 6, pause it, and then come back and check your answer when I show it on this video. So pause, try number 6, and then check your work. All right, now that you've tried number 6, we're going to go ahead and see what the answer was. So this 8 has a power of 1, the a has a power of 1, so those don't move at all. So I'm just going to move the c and the w and the x. So I hope those are the ones that you moved. You should have gotten a 8a, b4, and w5, and x2. The bottom should have c3 and y5. If these are backwards, that's fine. It doesn't matter. So this should have been your final answer. All right, let's go ahead and do the last few problems. So now we're going to put it all together, simplifying expressions and making everything positive when we're done with our answers. All right, so remember, first thing is to rewrite it. I'm going to go ahead and rewrite this. 10 over 22. Then we have x, 8 take away 3, y, 4 take away 7, and z, 5 take away invisible 1. All right, I'm going to reduce my fraction. I'm going to divide this by 2. That's going to give me 5 divided by 2 over 11. X to the 5, y to the negative 3, and z to the 4. All right, I've simplified my expression, so now I ended up with a negative exponent. Remember, our final answers, we want to keep them with positive exponents, so I'm going to rewrite this. So again, when I have this, these are all technically on the bottom right here of the fraction. So we're going to put a big fraction. I'm going to have the 5 on the top, 11 on the bottom. The x5 stays at the top. The y3 is going to go to the bottom. And the z4 stays at the top. And this is my final answer. All right, let's do the same thing on number 8. We're going to rewrite it, 60 divided by 45. Then we have m, 6 take away 5, n, 2 take away a negative 7. Be very careful with these. And then we have a p5, and there's nothing to subtract it with, so it just stays p5. Let's reduce this fraction by dividing by, you can divide by 5, but actually there's a bigger number. You can divide by 15. So I'm going to go with the bigger one first. Accidentally erased it, so here it is again. It might look a little different. So I'm going to go ahead and divide by, like I said, 15. So when you divide by 15, you get 4 over 3, m1, and 2 minus 7, the double minus adds, so 2 plus 7 is 9, and p5. Now in this case, I got no negatives, so I'm good. I can just leave my answer as is, or if you want to write it as a big fraction, you can write it as your other optional answer. You can write it this way if you prefer. Both answers are exactly the same. All right, let's go to that last problem. We're going to go ahead and rewrite it. Oh, this was actually a little different. We're just dividing by 4. So these are a lot easier. Just divide everything by 4. So 4 into 20x, that's going to give us 5x. Now we're going to go 4 into 12. That's going to give us 3. And that's my final answer. This is just a simple division because there's no letters on the bottom, no variable to make any big changes. So try number 10 on your own, divide by 8, and see what you get. All right, so you should have already tried it out. So 8 into 32, so we're going to have a negative here. 8 into 32 will give us 4x. And 8 into 40 is negative 5. But we also have, and I didn't go over this, we also have this negative out here. So this means everything gets multiplied by the negative. So that's going to be negative 4x plus 5. All right, so go ahead and start your practice pages and do your IXL problems as well. And good luck.